Saxon Advanced Math, Lesson 106.b. This is the standard form of an ellipse and that we've worked with. This is the standard form of ellipse. This is about the origin. This is not about the origin. This is its movement left and right and up and down. Now, we want to convert this formula from standard form, which are what these are in, into general form. In order to do so, it's pretty simple. We need to figure out what would clear the fractions. Well, clearing the fractions is going to be fairly easy to do because if I realize I want to cancel the 16 and cancel the 9, I can multiply everything by 16 and 9. Right? It doesn't even matter if it's the lowest common. It does cancel out the fractions, leaving with two binomials. Okay. Now we finish by multiplying this and arranging it. And so if we did so, we multiplied this out and arranged it. So they took the coefficient and they multiplied it into each one. Then they went ahead and squared the terms that were squared, and that would give us this. This is the general form. The general form of equation. This is the same idea of what we've done before. Is written in ax squared plus bx y plus cy squared plus dx plus ey plus f. And we're going to work with almost always where the conic sections are the b is 0, and that cancels this term altogether. Okay? Now let's look at how we work with this. 106.1. Example, describe the ellipse 3x squared plus 2y squared minus 6x plus 8y plus 5 equals 0. Begin by writing it in the standard form. Now, this is going to use a little bit of our math knowledge and thought processing, but what we're going to do is we're going to first of all, move the constant to the right-hand side. The next thing we're going to do is separate the x squared terms and the x term, the y squared term and the y term, and put them together. And we're going to use two sets of parentheses. Okay? We factor anything out that happens to have a coefficient in front of the x or the y. So they factor the 3 out, that left a 2. Factor the 2 out, that left a 4. Okay? The next thing we want to do is we want these to be perfect squares. So we're going to take half of negative 2, square it, which is 1, and put it here. But we really didn't add 1 to this side. We added 1 times 3. Now this is very similar to some of the other problems we worked, so this should look familiar to you. 1 times 3, which is 3, and we're going to add that to the right-hand side. I'm going to do the same thing here. Half of 4 is 2. 2 squared is 4. Added 4 in here, but I didn't really add 4 to the left-hand side of the equation. I added 4 times 2, which is 8, so I add an 8 over here as well. Okay? Once I've done this, I can simplify. Negative 5, 3, and 8 is 6. Okay, I can take this and factor it because it's a perfect square trinomial. It becomes x minus 1 squared. This one becomes y plus 2 squared. And all of a sudden I have very, very similar to what I need. But I need it to equal out to 1. That's the formula that I want it to be. So how am I going to equal it to 1? Well, I divide everything by 6. Okay, that's going to get it equal to 1. Still, we're missing out. Once I divide that, I get 3 over 6, which is 2, and 2 over 6, which is 3. But I want to find out what the square term is, because my formula is over a squared and b squared, or in this case it would be b and a. And so how would I do that? Well, I rewrite that as the root of 2 squared, which is 2. That's what that would have been. This is 3, so it's the root of 3 squared. And I write that in from the standard form to the general form of an ellipse.